So this is my Canada ML1022, better known as the Grizzly G0602, and I have removed the bolts and the compound lock to show you guys what the problem is and why I'm doing this modification. So when the workpiece is in the chuck, it rotates in this direction, which puts a downward force on the tool. And if you push down on the tool, because it has overhang from this point, I'll remove it here. You can see there's one bolt here and one bolt here. And what happens is when you push down on here, it causes this to rock. So the modification will be, this plate will have 6 holes in it, and 2 of them will be the originals and 4 of them will be extras. So that plate is basically replacing this plate. So I have removed my cross slide, and you can see the hole, threaded hole goes all the way through. That's the part that holds the compound on. So I'll be able to transfer those holes into the plate and then drill them out. Alright, so now we got our transfer punches. We put it in the hole. We've got the 2 pieces clamped together, and then a few light taps. Alright, so I've eyeballed up the hole here, and I'm just going to put a little oil on there, and we're going to drill that out. We'll switch bits and drill a pilot hole and then drill it out to full size. Just like that, we've got our pilot hole. Alright, let's find out if the bolt will go down into that hole. I'll have to take the drill bit out to find that out, because there won't be enough room otherwise. There we go. Look at that. Perfect fit. So what I just did was check the distance to the center mark here, or this one that I haven't drilled yet, and it's 10 millimeters. And so what I'm doing is I'm putting these holes 10 millimeter centers from each edge. So that's the plan anyway. What I'm going to do is now drill all of these with the starter bit, then drill a pilot hole, and then use my finishing bit. Because the vise actually contacts the mast back here, I don't have enough room to get to these holes, so what I'm going to have to do is actually spin the workpiece around and then do the holes, these two holes, while they're on that side. And there we have it. All of the holes are done. You can see that they all fit. A little snug, but it works. The next step will be transferring these holes now onto the compound rest, or sorry, the cross slide, so that I can drill and tap it. Alright, so now we've got our cross slide and the piece that we just milled. It's going to sit on there like that. Got the two bolts go in those holes. We're going to tighten it on and then mark these holes with the transfer punch. I'm not sure if the camera will pick these up, but we've got our holes transferred. There's a dot there, 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 and there. I don't think the camera will pick this up, but basically what I'm doing is I'm going to make a hole for this to fit in so that I can sit the compound down on there and see how much I need to cut away to get access to my bolts. So the reason why I made that hole is so that I can fit this on
when it's sitting on the lathe, it will be sitting like this. A lot of the time at this about this angle. And I need to be able to get a wrench in here. Now I can take some measurements and figure out how much material I want to remove. So what I've determined quite quickly, I'll remove a little bit more than the width of the head of the bolt to make sure we got lots of room for a wrench, and I'll just take a cut this way and this way with the end mill to make sure that I have lots of clearance. Alright, I got it set up. I'm going to make the groove 3/4 of an inch by 300 thousandths will give me lots of room for a bolt and a wrench. Actually, I may go 400 thousandths. I'm going to go 400 thousandths. Let's see what happens here. Ended up being 400 thousandths by about 20 millimeters, so that my bolt can go in there and my wrench can fit in. Now I need to spin the piece around 180 and do the same thing over here. Alright, so I've got it down to 400 thousandths by 20 millimeters on both sides. So it goes together like that. So I need to cut the bottom of this so that it goes in like that. So I'm going to try to mount it in the 4-jaw chuck in my lathe. I basically faced this just to make it start cutting even. I thought maybe it would reduce chatter. We've got that hole indicated, basically centered. So anyway, I'm going to try to cut that out now and see what happens. It's actually cutting a little bit. Princess Auto Cutter, which is basically the Harbor Freight of Canada. It seems to be working. I think I'll do a time lapse. This is going to take a while. did it. See if it'll come out. This is the piece of material that we've removed. 2.75 is what the diameter all the way through needs to be. And then there's a second diameter that is cut as a recess. Alright, after a whole lot of boring with a squealing boring tool, it looks like I'm ready to do a test fit. Okay, so it looks like I've got a few thou more to go. I might just try to clean it up with sandpaper because I want this to be a really tight fit. It's loose around the outside here, which it's supposed to be. I need clearance so that it doesn't rub off the numbers. This part here doesn't even have to be terribly tight, but I want it to be fairly snug for two reasons. One, to keep debris from getting in there. If it's got a really small hole, then the big chunks of stuff can't fall down in there. And the other reason is because it'll just make it that much more secure. So it's measuring right with my guesstimators. If I loosen up the chuck, it would probably fit, but I'm just measuring with this and they're not very accurate. So I'm guessing that if I just loosen up the chuck, take some pressure off, it'll probably fit in there. If not, I'll just put some sandpaper to it and see what happens. It's about 1 in the morning now, so I'm having a hard time putting words together. I haven't eaten yet today, so I should probably do that too. What I'll probably do is leave this till tomorrow, and yeah, I'll get back to you guys.